Hello, this is Mrs. Salisbury. Several students requested some more practice with trig identities, so here you go. I've got a couple practice problems that I'll go through with you just to give you some more examples. Before you watch the video, you should have your identities in front of you. We'll be using the quotient identities, the reciprocal identities, and the Pythagorean identities. As always, if you like this video, make sure to like and subscribe. So let's start with this example here. We have cosecant theta times tangent theta. So one of the things that I like to do is just change everything into sine and cosine. And a lot of times this will allow you to start canceling things out, which will then simplify it. So I know that, so think about how you can turn cosecant theta and tangent theta into sine and cosine. So take a moment, look at your identities, and see if you can figure out how to do that. Okay, so cosecant theta I know is 1 over sine theta. That's one of my reciprocal identities. I know that tangent theta is sine theta over cosine theta. That is one of my quotient identities. Sure enough, I get something that can simplify, that can cancel out, which leaves me with 1 over cosine theta, which I could rewrite as my reciprocal identity, secant theta. And you can't get any simpler than that, so we are done. Let's look at another one. So here I've got sine squared theta divided by tangent squared theta. So I'm a little torn about what strategy to take because I see the squares, which makes me think Pythagorean identities, but I know if I can cancel some stuff out first, that might be easier. So this is one of those ones where it's not completely obvious which direction to take. So just choose one. That's really what you have to do with these. You don't always know what's going to work, and you just have to try something. I'm going to try changing everything in a sine and cosine because that's just easier. So let's give that a shot. And I'm going to really break this down into lots of steps because I want to make sure that you understand what I'm doing in each step. So I can rewrite this as sine squared theta times 1 over tangent squared theta. And remember, I can always rewrite something over 1. So then, well, I know that 1 over tangent squared theta is my cotangent squared theta. So I can then rewrite this as sine squared theta over 1 times cotangent squared theta over 1. And I can use my quotient identity to change my cotangent squared theta to cosine squared theta over sine squared theta. So I actually use my reciprocal identity before I split it up into sine and cosine. So here, I can cancel out my sine squared thetas, and I am left with just cosine squared theta. Can't get any simpler than that, so I am done. Let's do another one. Let's say I've got cosecant squared theta minus cotangent squared theta, all of that over 1 minus cosine squared theta. So as I go through these, good idea to write this down with me and make sure that you're pausing and kind of thinking about what you would do at each step. And again, remember that there are multiple ways to proceed. So just because you decided to do something different than what I did doesn't mean that you're necessarily wrong. It's just you decided a different path. There's usually many, many different ways to get to the most simplified expression. So looking at this, I definitely think about my Pythagorean identity. And I particularly think about the one that has both cotangent squared and cosecant squared. So I'm thinking about cotangent squared theta plus 1 equals cosecant squared theta. So I've got in my numerator cosecant squared theta minus cotangent squared theta, which I can get if I subtract cotangent squared theta from each side of this Pythagorean identity. And that leaves me with 1 equals cosecant squared theta minus cotangent squared theta. So that means I can replace this with just 1. I also see another Pythagorean identity. When I look at that denominator, I see that original Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. And if I subtract cosine squared theta on each side, I get sine squared theta equals 1 minus cosine squared theta, which is right here. So that means I can replace that expression with just sine squared theta. So notice that I used 2 Pythagorean identities and I just rearranged them a little bit, which is completely fine as long as you're following the rules of math. So now I've got 1 over sine squared theta, which I can then write even more simply as the reciprocal cosecant squared theta. Doesn't get any simpler than that, so I am done. Let's do another one. So in this example, I've got cosecant theta minus sine theta, all of that over cosine theta. So this one for me is a little bit of a head scratcher. I'm not entirely sure how to get started here. I don't see anything squared, so Pythagorean identities don't really jump out at me. I could change everything to sine and cosine, but the only thing that's not sine or cosine is that cosecant. So, I mean, I can try it. I'm just going to try something, because this is one of those things where you may not see it right off the bat. Just got to try something. I don't think this is going to get me anywhere, but I can try changing that into 1 over sine theta minus sine theta. Okay, and then cosine theta is still at the bottom. So I just changed that in terms of sine. So, where can I go from here? Oh, actually, this might actually lead me to where I need to be. So sometimes when you get an expression like this, where you've got fractions within fractions, sometimes it's useful just to multiply everything by that denominator. So in this case, I've got this denominator of sine theta here. So if I want to get common denominators here, so I can subtract these two, let's see what happens here. And again, I'm not sure if this is going to do anything. This might just be a path to nowhere, but I don't know what else to try, so I'm going to try it. And that's honestly just what you have to do for these things. So that leaves me with 1 minus sine squared theta over sine theta, and all of that over cosine theta. So I've got my 2 fractions, this one and this big one, that I'm subtracting common denominator of sine of theta. And actually I'm feeling a little good about this because I know that 1 minus sine squared theta, that's one of my Pythagorean identities. If I take my cosine squared theta plus sine squared theta equals 1, and I subtract sine squared theta from both sides, I get cosine squared theta equals 1 minus sine squared theta. Now I'm getting really excited because I can take this and I can now replace it with cosine squared theta. Oh, this is beautiful. Okay, cosine squared theta at the top over sine theta. All of that over cosine theta. All right, so now, notice one thing I just want to point out before we move on is notice that I'm writing this big fraction bar a little bigger just to clarify what goes where, just to kind of keep it straight visually and in my mind. All right, so here I'm taking a fraction here and I'm dividing it by this. So that's the same thing as taking this fraction here, cosine square theta over sine theta, and multiplying it by the reciprocal. I'm just going to leave it as 1 over cosine theta for now. And we can see I've got these two cosines. I've got 2 at the top, 1 at the bottom. I can cancel out a pair, and I've got cosine theta over sine theta, which is, using my quotient identity, cotangent theta. Wow, that was a great example because I honestly was not sure how I was going to start that one. But I just went with it. I tried something. Look at the top. Going back to the beginning, I just tried something and it ended up getting me where I needed to go. So just try something. You can't get anywhere if you don't write something down. And sometimes when you write it down, just getting it visually will lead your brain where it needs to go. So always just try to write something down, even if you don't think it's going to get you anywhere. I really didn't think it was going to get me anywhere, and it ended up getting me to the answer, which is super cool, which is why I love these identities, because they really are just like puzzles. And it feels so great when you actually get one, especially when you start off not really being sure about it. Let's do another one, now that we're on a roll. Last example, secant squared theta times cosine squared theta plus tangent squared theta. Oh my. Alright, so I'm going to try writing everything in sine and cosine. I'm hoping something on the left cancels out when I do that. So think about how you can rewrite those as sine and cosine. So on the left, thankfully, these guys cancel, and I'm left with 1. Now, notice here on the right, I did split it up into sine and cosine, but now I'm thinking I want it back to tangent. And the reason I'm thinking that is because I've got that identity, 1 plus tangent squared theta equals secant squared theta. So then that means this equals just secant squared theta. So that happens sometimes. You change it and then you realize, oh, you know what? I should probably change it back, because you start to see the pattern when you see it laid out in front of you. So you really just got to try these things, know your identities well, have them in front of you so you have that visual, and just try something. Even if you don't think it's going to work, try it. Maybe you go back to what you had, maybe you start over and do something completely different. That's completely okay. But you want to try something and have fun with them. Don't stress out over them. See what you can do, and good luck.